20, we got D. Do I need to explain it?
Yeah.
Okay, so it says that each triangle is a reflection of another triangle across the given lines. How can you describe triangle 3 by using a reflection rule? Well, what's it a reflection of? What is triangle 3 a reflection of? Which triangle?
2.
Triangle 2. Across what line?
1.
L.
Oh, sorry.
No, it's, I mean, but that's what, this one's M. The only reason I can tell that, because I can't see. So, it's a reflection of triangle 2 across line L. So this is what it's saying, a reflection across line L of triangle 2. Does that make sense?
Yes.
That's how you write those. That's all that one is. Okay, then on number 21, they need us to graph it. Let me get my graph paper, or graph stamp. Okay, I'm going to graph these points. That's half my credit, okay, for this problem. So it says over 1, up 1, 2, 3, 4, 5. That's point A. Over 5, 2, 3, 4, 5, up 2. Possibly, yeah, or I'll give you a graph. I'll go through it and make sure. C is over 1 and up 2. Oh, and that's it. So it's a triangle. So I'm going to draw my triangle, ABC. Everybody's good with the first part, right? Now it says reflect it over y equals 0. Well, y equals 0, I don't go up or down any, right? Y equals 0 is this horizontal line. Do y'all remember that? Yeah. If it says y equals, it's a line that goes this way. If it says x equals, it's a line that goes up and down. Now, if I'm going to flip it or reflect it over that, then I just count how far are each of my points. Well, this one is 1, 2 spaces. So how many am I going to go down? 1, 2 spaces. Thank you. This one is how many spaces? 2, so I'm going to go down 2 spaces. And this one is 5. 1, 2, 3, 4, 5. So there we go. And I'd call them like A prime, B prime, and that matches the C. Okay? Does that make sense? There's our answer. All right? Number 22. Okay, the best way to do this, oh, it tells us, never mind, we don't even have to find the degree. It says, how much are each of these angles? They are 30 degrees. So I know that this is 30, 30, 30. Do y'all understand that? Okay. Every one of those is 30. If I added them all up, it would be 360 when you go around a full circle. Okay? Now, it says if I start at G, so everybody find G right here. Okay? And what way are we going? I already told you this. We have to go counterclockwise because that's what the book told us in this chapter. It said go counterclockwise. So it says the hexagon, and triangle FIN. I'm trying to find that. Okay. It says, what's a rotation of G for 240 degrees? So what are we going to count by? 30s, right? So I'd have 30, then what? 60, then what? 90, then what? 120, and then again 30, 60, 90, 120. So what is our answer? K. I just did 120 plus 120 was 240. That was easier for me to count. Okay, so that's number 22 is C. Now 23, it's the same idea. It says OL, so I'm going to make a mark that this right here, this little line is OL, right? Hold on. Let me get that camera down. Okay. So we have OL, and we're going to go 120 degrees, right? So we're counting by 30s again. So 30, 60, 90, 120. So what line is this right here called? OH. So that's why it's D. Does that make sense, y'all? To me, those are good. Like, it tells you, you're just counting by 30, and it tells you to do that. Okay? And it's just talking about...
It tells us.
Yeah. Well, it would be just like these if I keep those problems. Okay. Number 24, we have to graph and then graph our rotation. So let me do a little graph stamp real quick. So the first thing I'm going to do is graph those points. I have 3, negative 5. I have 1, negative 3. Negative 1, negative 5. And 1, negative 7 would be right there. And I'm going to connect my points. I should have written them. That is W, X, Y, Z. Okay, now it says it wants us to rotate them 90 degrees. All right, so what you're going to have to do is use your rule. Can anybody tell me what the rule is? What do I do to these ordered pair? There's 4 ordered pair. I think I switch them and make one the opposite. Yes, so that means you're going to take your Y value. This is what your rules state. You have to understand your rules. You're going to make your Y value the opposite and write it first. So instead of negative 5, what would I write? 5, and then I keep my X the same. What do I write for my Y value this time? 3, keep my X value the same. And notice we're switching them. Make that 5, my X value stays the same. Make that a 7, and my X value stays the same.
What if, say it's like on Z, what if it's negative 1, 7?
Okay, then I would have made it a negative 7. I would have made it the opposite, but kept the negative 1. Yeah, you're just changing it to the opposite. That's why I'm not saying make it negative or make it positive. Make it the opposite of what it was. Okay? Yeah, on that one, on the rotation of 90 degrees. So that's what it says. Make your Y the opposite and keep your X the same and write them in that order. Okay? Now, then it wants us to graph those new points, okay? So I would go over 5, 1, 2, 3, 4, 5, and up 3. Hold on. Over 3, up 1, over 5, down 1, and over 7, up 1. And there's our rotation, our 90 degrees on that graph.
Do you want us to put the prime for it?
Yeah, I should have done that. There you go.
So now, can you like move the
I think I wrote
camera
those.
icon?
I may have written those wrong. Can I move what? Hold on, let me.
Look at that little camera.
Oh, like that?
Yes.
Okay, let me actually see. I might have written those wrong. W was the 5. 1, 2, 3, 4, 5, 3. That one's W. The X was the 3, 1. The Y was the 5, 1. That's Y. And that one is Z. Okay. That's Y. That's Z.
You did a really good job. Alright, move on to the next one.
Okay. The next one, y'all are in a hurry.
You want to do this?
25. It says, draw the image of the figure after the following rotations. It says we're going to rotate it 90 degrees and then rotate, I'm trying to read it. After the following rotations. 90 degrees and another 90 degrees. So I'm guessing we could just rotate it what? 180. But what I would do is I would mark these points. This is, it's kind of hard to tell. I'm guessing 4, 3. What's this one? 6, 1. What's this one? 3, -2, and this one is 1, 0. Okay, if I was to rotate them, let's go ahead and do that. If I rotate those 90 degrees, okay, what are my new points going to be? I'm not going to graph them, I'm just going to write them. I hope I'm still recording. If I rotate them 90 degrees, remember it's the same thing. We switch it, so it's -3, 4. For -1, 6. 2, 3. We make the Y value the opposite. 0. This is 90. I was just going to go ahead and do 90 first, like it says. And then I'm going to do now, what am I going to do again? 90 degrees again. Okay? So now I'm going to have all these, prime, prime. So what's my A going to be? And we probably could have just done it 180, but I'm doing it exactly like they say. So it would be what? -4, -3, -6, -1, -3, 2, -1, 0. And I'm pretty sure that's your rules for 180. So then I would graph those points. I'm going to use a different color. I think this one works. So I would go over -4 and down 3. I would go over -6 and down 1. -3 and up
By 2s.
2. Huh?
Let's count by 2s.
Yeah, well, yeah. So it's like 1, 2, 3, 4, 5.
Oh, okay, I see.
Yeah, this one was -1, so I didn't go quite. And then -1 and stay there.
But it could have worked if we used the 180 rule too.
Huh?
Like,
Yeah, it could have just done the 180 rule. But I was just writing both of theirs so you could see on
do you
that.
want us to write both of them?
All I'm going to look for is your image. This right here. Do it.
Are we gonna?
Yeah, you're going to have your note card. You're responsible for your note card. Let me write these letters. The C is this one. And the B is this one. So there we go for that one. Okay, are we good?
Oh, I didn't write any of them.
All right. Are we ready or no? Y'all are writing?
Oh, we're good.
Number 26. What are two reflections across intersecting lines? Do y'all remember what that is? I'm probably not putting this one.
I'm thinking glide reflection also.
That one, you could draw a picture. This is what intersecting lines looks like. We'll call this line X and Y. If I drew a triangle and it says two reflections. If I drew it on this side, it would look like this. And if I drew it on this side, it would look like this. It's actually a rotation. That's hard to tell on mine, but it is a rotation. I probably won't put that one on there. I mean, that one's just memorization though. So you would want that.
Yeah, I kind of do want that one.
It's going to be out there.
Yes.
Wait, can we have to figure on that?
I just didn't know if y'all would be able to remember that.
Yeah, I feel like I could.
Okay. We'll kind of go through and see which ones we're going to mark off in a little bit. We'll do that together. Okay. 27, it says you have a glide reflection. Find the coordinates of P. It wants you to go backwards on this one. I don't think I'll do that one because we hated that. We remember we did that one on a worksheet and it was terrible because we had to do everything backwards.
So can we skip that?
Yeah, we're going to skip that one, but let me make sure I mark that off. But I do really like D. Yeah, mark 27, not D, 28, the one with the D. It says it wants us to, remember you always do the second thing? That's why 27 is just backwards, so we're skipping that one. But we reflect across line L. So if I reflect across line L, this is hard, then it's looking like that, right? Does everybody understand that? Now, if I reflect it across line M, what's going to happen? It's going to flip back over. And I know, it's difficult. It's very difficult. So, but that's all it's looking for on 28. That's a good one.
It's a good.
Yeah.
That's a really good one.
Yeah, I like that.
This man, can I use the restaurant?
Mm-hmm.
I got it.
Okay. We're ready to keep going? Okay. Find the glide reflection image of the black triangle. Okay, this one's nice. I like this one better than 27. It's okay. It's not going to show. So we're going to start at our black triangle, and we are going to move it first. Remember, you always do this one first. and then reflect it. Okay, so you kind of have to pick and see which one looks like it's actually reflected. So this one means it's moved down 7. So if I take that point, we're counting by 2. So 1, 2, 3, 4, 5, 6, 7. I think we're moved down further than this one, right? So it's not A. Well, and let me just try this one. If I'm going to move it down 7, 1, 2, 3, 4, 5, 6, 7. The bottom of my triangle would be here, right? So it's not B. So it's either C or D, right? So let me bring it down. This is kind of what my triangle would look like if it was moved down 7. It's going to match both of those somewhat. Does everybody understand that? That's translated down 7. But now what's it rotated over? X equals 1. So let me show y'all that the line x equals 1 is this line right here. Which one of those is flipped over that line? D. It's D. Because there's an equal space from the pink triangle to this one. Does that make sense? That's what you're looking for. This one has a bigger gap, so it wasn't reflected over that line. So it's D. Yes. All right, moving along. Number 30. I haven't really looked at these yet. Okay, write a sequence of rigid motions that maps triangle RST, oh, these are kind of difficult, to DEF. So what's happened to RST to DEF? First of all, yeah, it has been rotated and reflected. I think it was reflected. Not across that. Little r is rotate, and they're going to put the degrees with it. Okay? But the big R, why does it say? Yeah, reflected across ST. Where is it? I think we're not going to put those.
Okay.
But let me see about 31.
So we can mark out 30?
Yeah, mark out 30, but I think I might like 31. Let me see. Because to me, it's not reflected over that. I don't know. I think I'm going to mark that one out too. Because they pick different routes than I do. And then it's hard to know what they did first. Like, does this make, that probably doesn't make sense to you. But one of them, they're saying, okay, I rotated it 90 degrees, then I moved it. But what if we moved it first and then rotated it? I think that would just take forever for us to do. Because remember, you've got 45 minutes to take this test, this whole test. So I don't think we have time for that one. Now, well, okay, think about by the time you get in here and ask a question or two, because we really don't have time for questions. I mean, y'all have, honestly, I would say, I mean, it's supposed to be 50 minutes, but I don't know. Okay, look at number 32. Super easy. Which ones are congruent? Which ones look the same?
B and D.
B and D and
E
E and F. So number 32, you get C. Right? Can y'all tell that A and C are not congruent because they're not the same size? Yeah. There you go. Okay, number 33. I did like this one too. It says, first of all, remember you're going to the dotted line. All right? So you're going to, where are our letters? It just says the dashed line figure is a dilation from EFGH. So did it get bigger or did it get smaller? You're looking at the dash. They call it a dash line. I call it a dotted line. Yes, so it's an enlargement. That's what you're going to say. It's going to be the same on your test. It's always, what is the dotted line? Well, it's an enlargement. Y'all, that's half the credit on that. That's all you had to say. But then it says, now you have, well, so it's either A or B. Sorry, it's either A or B. Now you have to say the scale factor. So you're looking at, did it get 6 times bigger or 3 times bigger? But let's write it out and see. What is our distance here for our little one, our little shape? You're counting by 2s, so it's 1, 2, okay? So if I got bigger, I'm putting my bigger number on top, smaller number on bottom. When it's bigger, put the bigger number on the top, okay? So what's the bigger object? How many is it? 1, 2, 3, 4, 5, 6. So it's 6 over 2. What is 6 over 2? It's only 3 times bigger, okay? So it's B. Does that make sense? If I counted and I had the numbers 8 and 4, what one would go on top? Since it got bigger, it would be 8 over 4. Does that, okay?
Oh, and then
If it's smaller, the smaller number goes on top because then you want it to be a fraction if it got smaller, okay? Because you would want it to be half the size, okay? Look at number 34. Here's our dashed line, and it says, is it an enlargement or a reduction? So this one you're going to say, that's your half credit, reduction. It was reduced in size, and now we're going to put the smaller number in the bottom. So it's counting by 2s, y'all remember that, okay? So it's 1, 2, 3, 4. Does everybody see that that's 4?
Do
Yes?
that again.
Okay, I just did 1, 2, 3, 4. Because each block is really 2. So 2, 4.
So how do you know where to put the number?
Okay, if it's getting smaller, then you put, I did the smaller number in the numerator. Sorry. I was just about to say, if it's smaller, you put the smaller number in the numerator. If it's getting bigger, you put the bigger number in the numerator. I said that and then I wrote it in the wrong spot. If it's smaller, you put the smaller number in the numerator. If it's getting bigger, you put the bigger number in the numerator. Now, what is our bigger object? We're counting by 2s. 2, 4, 6, 8. So what is it? It's a half smaller. So y'all, if it's getting smaller, it should be a fraction. Okay? If it's getting bigger, it should be
Where
a
did
whole
you
number.
count 8 at?
Oh, I counted this side, and I just did like 1, 2, 3, 4, 5, 6, 7, 8. Because they were counting by 2s. Does that make sense, y'all? Okay. Smaller, you put the smaller number in the top. If it's getting bigger, you put the bigger number in the top. Okay, number 35. It says a blueprint for a house has a scale factor of 45. A wall in the blueprint is actually 9 inches. What's the length of the wall in real life, the actual wall? So if I'm looking at 9 inches, but the scale factor is 45, all you're going to do is multiply those. What's 45 times 9? Anybody?
405.
Probably 45.
Divide that by 12, and can somebody tell me? Hold on, let me see something. Because it's,
Yeah, 4 times.
I got 405 as well, but then we were in inches, so you had to divide feet by inches. So divide that by 12, and what is it? 33.75. Y'all, if you're looking at a house, is the wall going to be 405 feet? But it's, you're going to feet. You were in inches, so we got 405 inches. But how many feet is that? 33.75. But I need you to look at all these answers and think realistically. Is your wall in your house going to be 405 feet tall? No. Doesn't 33.75, that sounds a lot better. It might be like a 2-story home. Okay, yes. All right, so does everybody understand that? You multiply those, divide it by 12. It's just because you're units.
It actually 4,000.
Okay. This one, I really like the way this one's worded better. You can set it up easier. A microscope shows you an image of an object that's 140 times the object's actual size. So the scale factor of the enlargement is 140. An insect has a body length of 6 milliliters. What's the body length under the microscope? Okay, so let me see how I did this one earlier. Shows you an image that is 140 times the actual size. The image is 140 times the actual size. What's the actual size? 6 millimeters. So 140 times 6. What is that? 840?
Sure.
Which one is it? We didn't even change any kind of measurement.
D.
D, 840 millimeters. We didn't change any measurement on that one. Isn't that one better?
Yeah, I
Yeah.
like that one.
Well, because you can just set up a little equation. The image is 140 times the actual size. That's what it says. Image is 140 times A. They give you A, you multiply. I like that one a lot better too. Okay. 37. It wants us to dilate this graph by a factor of what? What number do they give us? 2. Okay, so what you need are these actual points. What is point A? Well, we're counting by 2's. It's negative 2, 4. Does everybody see that? Yes. What is point B? It's 4, 2. Does everybody see that? And what is point C? Negative 4, negative 4. We're good with all those? Now, if we want to change it by a factor of 2, that means we are multiplying by 2. So my new A is what? Negative 4, 8. What did I do with those numbers? Multiplied them by 2. My new B,
But like they could have multiplied it by like 3 or something.
if it had a 3 right here, then I would have known to dilate them by a factor of 3. If it would have been 1/2, what would I have done? I would have taken half of those numbers, made it smaller. But I'm doubling. 8, 4. Y'all getting this, boys?
Boys in the back.
Boys in the back. Okay, so here's my new object, right? And then I would graph it. So I'm going to go over negative 4 and up 8. There's A prime. Over 8 and up 4. B prime. Negative 8 and down 8. And that's C prime. And it should be if I could draw good, the same shape of the triangle. It's just what? 2 times bigger. So you should see the same shape. That's a good one. Let's see. We can do number 38. I'm going to make a little graph, I think. Ooh, that's terrible looking. Look. Okay, was everybody ready for me to move on to 38? We may not do 39. I'm not sure if we learned that or not in that last lesson. So, I guess I will start. It says that this triangle is translated 4 units to the left. So, y'all, I'm going to write those new points real quick. All right, if I move 4 units to the left, what's my new ordered pair from 0, 0? If I'm negative 4, 0. Does everybody see that that moved me to the left 4? What's this one going to be to the left 4? 1, negative 1? Where did I get that? What your 5 minus 4 is what? 1. Now let's look at point C. Let's change it. You're at 3 and you move to the left 4. Huh? Oh, move the camera. There you go. So 3 minus 4 is what? Negative 1. 7.
We only do the F.
Yeah, because it's left. Remember, if it was right, I would have added the number. But if it was the Y value, I would have moved it up or down.
Wait, how did you do it?
Okay, so what I did was here's my ordered pair. If I move them to the left 4, it's basically right here. Do you want me to just graph it and let you move it that way? Do you want to graph it and then move it?
Yeah.
Okay, so let me graph the points they give us. 0, 0, over 5, down 1, over 3, 2, 3, up 7. Okay, if I was to take each of these points and move them to the left 4, watch where I am. 1, 2, 3, 4. I'm right here at negative 4, 0. Okay, but that's okay if you didn't know that. Move this one to the left 4. 1, 2, 3, 4. Okay, which is at 1, negative 1. Move this one over 4. 1, 2, 3, 4. So here's my translation. Is everybody good with that? I have just moved it over 4. If you didn't want to write them like this, you can just graph it. But then what does it say that I'm going to do? I'm going to dilate it by a factor of 2. That means I have to write what all these ordered pairs are, which I've already done, and multiply them by what? 2. Are we good with that? So you would have to figure out, if you didn't already know, what are these 3 ordered pairs? And then we have to multiply them by 2. Okay? But y'all, you don't have to graph it. All it wants is what? What are the vertices?
What do you mean by that?
The ordered pairs.
Yeah, but do you want us to multiply by 2?
Yep, I'm about to multiply them by 2. Yeah, you have to move it to the left first and then multiply by 2. So that's what I'm about to do. Yeah? Sure. So I'm going to multiply. What's negative 4 times 2? 0 times 2. 0. 2 times 1. And then 2 times negative 1. 2 times negative 1. And 2 times 7. This is all I'm looking for. I don't need the picture. I just needed you to move all those points to the left, 4, and then multiply them by 2. Okay, that's all they wanted.
So we don't have to graph that?
No, you didn't have to graph any of it. It didn't say 2. It just says, what are the vertices? I'm wanting to say, yeah, we didn't do 39. When I put this on here, I just thought it was saying what's the dilation, but it's not. It's way more than that. So we're not going to do 39. Okay, I'll mark that one off as well. So that's the test, or your study guide.
Do you have any more note cards?
There's probably some in that drawer. So what you're going to do for the rest of the day,